All right, so today, no, we have to start recording. You can ask me later, though.
Okay.
Today we are going to cover section 8.6. And we're going to be working with a lot of radicals, a lot of square roots, cube roots, fourth roots. All right. Well, first of all, what we're going to do, if we're looking for the inverse of a function, you know what, before we do that, let's take a look at domains. Let me get this stuff off the board here. We're looking for domain. All right. Let's take this first problem up here. F of x equals 5x plus 18. Now, when you're talking about a domain, you're talking about an x and a y. You're talking about real numbers. And we know that the x is your domain, the y is your range. We're not going to talk about range, we're talking about domain. We have a function up here, f of x equals the square root of 5x plus 18. That's the function. What is the domain of this function? What can x equal? Are there any restrictions? Well, when you're talking about domain and graphing and those things, you're talking about real values. Therefore, 5x plus 18 has to be greater than or equal to 0. Because we can't have a value for x that's going to give me a negative number underneath the square root. That's not a function. It's not the definition of domain. We need real numbers. Okay? So what's underneath the radical has to be greater than or equal to 0. And that's an easy one to solve. We subtract 18 from each side. Divide by 5. So as long as my x values are greater than or equal to negative 18 over 5, we're good. Does that make sense? If x were less than negative 18 over 5, we would have a negative value underneath the square root sign, and we can't use that when we're talking about functions. The next one, if I can remember. I believe this is 5x minus 12. All right. So what is the domain of that function? I can use any x value I want as long as 2x squared plus 5x minus 12 is greater than or equal to 0, as long as it's a positive value. Well, let's factor that. And the problems you'll have today, you'll be able to factor that. You won't have to use quadratic formula. All right, so we'll factor 2x and x. It could not be 6 and 2. It's not even a possibility. Or it could not be 2 and 6. And the reason why is if I put a 2 here, that means I could factor a 2 out of this first parenthesis. And if you can't factor a 2 out of the original, you can't factor a 2 out of one of the factors. So I know it's not going to be 2 and 6. Or for the same reason, oh, I got to do all this stuff. Cancel. There we go. For the same reason, it can't be 6 and 2. So I'm thinking it's going to be 3 and 4. It just makes my factoring easy if you know all these rules, but the signs will be different. Outside terms 8x, inside terms 3x. I can get 5x out of 8 and 3, so I'll make a plus and a minus. Does anybody know? Well, let's do this. My zeros are 3 halves and negative 4. And which value do I want to use? Well, what I have to do graph this on a number line to see what works and what doesn't. Michelle, what do you think?
Hold on, I said a question.
Yep.
So 3 has a negative 4 would be the
No. 3 has a negative 4 other zeros. All right. Your domain, you have to find by putting it on a number line. Here's 0. Here's negative 4. Here's 3 halves. I just want to see what works. Because it's greater than or equal to, I'm going to get, I can use these values. So they're going to be closed in circles. So the question is this going to be a conjunction? A disjunction? Do we know before I test any values? You remember? No? Okay. Well, let's test an interval. And I think the easiest number to put in is 0, isn't it? Go back to the original function and put in 0. I would have 0 plus 0 minus 12. Square root of negative 12. It's not going to work, is it? We need it to be positive. If 0 doesn't work, there's not going to be any numbers in this interval that will work. So you'll find that x has to be greater than 3 halves, or, and so that's a disjunction, x has to be less than negative 4. Are you unsure about this one? X is less than negative 4? Put in negative 5. Negative 5 squared is 25. 2 times 25 is 50. 5 times negative 5 is negative 25, and then minus 12. That gives me a positive value, so we can use it. Right? If one number less than negative 4 works, they all work. Okay? So that's finding the domain. Any questions on that? All right. Describe the transformation. In green, I've graphed the parent function. The parent function, we're dealing with radicals. F of x equals square root of x. And over on the right here, you can see what that function looks like. Sort of this half parabola. Okay, let's describe the transformation. What about the positive 4? What does that do to it? Shifts it 4 up, right. This is a shift. All right, more importantly, a vertical shift. And so that is shifted 4 units up. What about the 1?
1 to the left.
1 to the left. There's another shift. Whenever you add something or subtract something, it's a shift. And because it's inside the radical, it is a horizontal shift, 1 unit left. 1 unit left. And that is a horizontal shift. Okay? And what does the 2 represent? A stretch. That is a vertical stretch by a factor of 2. That means I'm taking the ends of those vertically and stretching them. So I'm taking this half parabola, I'm moving it up 4 units to the left 1, stretching it by a factor of 2, and then what about the negative out front? It's reflected. Which way? Horizontal or vertical? Vertical. So we have this becomes a vertical reflection. Turns it upside down. Okay. So if we move this up 4, stretch to the left 1, you're liable to get something like something like that. Okay? Might even be below that y-axis, I'm not sure. All right, so describe the transformation. So we have to remember what we learned back in chapter 2, I think. All right. Now let's get to the inverses. Find the inverse. Y is equal to, let's take an easier problem. X squared plus 12. Okay, in order to find the inverse, switch the x and y. And solve for y. Subtract 12 from each side. Simple. Then what? Square root both sides. So y equals what? Y equals what? Plus or minus. Don't forget the plus or minus. The square root of the whole thing. X minus 12. It is not the square root of x and the square root of 12. It's the square root of x minus 12. Okay? That's easy enough. Those are the easy ones. Any questions on that? Because I'm going to erase that because I'm going to need some space. All right. Let's take a look at the one above. Switch the x and y. X equals, I've got to switch both x's here. Y squared minus 2y. Okay, well, I'm going to save a little bit of trial and error here, but you cannot solve for y the way it sits. You could factor out a y times y minus 2. You still can't get y by itself. So what can we do? Well, I'm going to set the equation equal to 0 by subtracting the x from each side. That's the first thing we do. And what does y equal? Well, it doesn't factor. So what do I have to do? Complete the square, but it's a lot easier to use quadratic formula. Okay? Quadratic formula. Just a reminder, not x equals, but y equals, because this is a quadratic and y. Opposite of b, plus or minus square root, b squared minus 4ac, the discriminant, all over 2a. So let's identify, if you complete the square, I'm going to have to add something and then subtract something, and then it's really tough. My a is 1. My b is -2. And my c is -x. It's that whole thing there, the -x. That's my c term. Not -1, -x. That's important. Identify your a, b, and c. I'll plug it in. The opposite of b, 2, plus or minus the square root of b squared, always positive, minus 4ac, all over 2a. The hard part in all this is going to be figuring out what your discriminant is. Plus or minus the square root. Now, I have 4, and then -4 times 1 is -4. -4 times -x is a positive 4x, all over 2. And now we have to simplify that radical. underneath. I can't take the square root of the 4 and the square root of the 4x. I can't do that because I have to factor it first. 2 plus or minus the square root. Let's factor underneath the radical, and it becomes 4 times 1 plus x. Now I can take out the square root of 4, which is 2. So I have 2 plus or minus, square root of 4 is 2, square root of whatever's left inside, the 1 plus x, all over 2. Follow me? All three terms now can be divided by 2. In the denominator, 2 divided by 2 is 1. I've got 1 on top. These 2's do not cancel. They're divided by. Plus or minus. That's a 1. And that's a 1. And that's 1 plus or minus the square root of 1 plus x over 1. And I don't need the 1 on the bottom. That's the inverse. Okay? Next one. Y equals x squared plus 4x plus 4. Find the inverse. Switch the x and y. All right, every problem is done the same way. Switch the x and y. Set the equation equal to 0 by subtracting x from each side. Identify your A, B, and C. A is 1, B is 4, C is 4 minus x. That's your C term. Okay. Quadratic formula. Opposite of B plus or minus square root of b squared, always positive, minus 4 a c all over 2a. 2 times 1. Okay. Now let's figure out our discriminant. All right, I've got 16. Negative 4 times 1 is negative 4. Negative 4 times 4 is negative 16. And negative 4 times negative x is a positive 4x. All over 2. Simplify inside the radical. Negative 4 plus or minus the square root. 16 minus 16 is 0. And I'm left with 4x all over 2. And yes, now I can take the square root of the 4 inside. So y would equal negative 4 plus or minus 2 square root of x all over 2. And reduce. All three reduce by 2. And I get negative 2 plus or minus 1 square root of x over 1. That's my inverse. If I graph the original equation, I'll get a parabola. if I graph both of these, negative 2 plus the square root of x, and negative 2 minus the square root of x, I will get a sideways parabola. And it's going to be symmetric over the, you know what? Symmetric over which axis? We forget. What is the axis of symmetry? Y equals x. It's a diagonal, right? And I think I did that. Is that the one? No, it was the first one I think I graphed, right? Yeah, x squared minus 2x. Then I graphed the inverse. And there's the original. There's the inverse. And then if I graph that line, y equals x, see that it's a reflection over that axis. All right? Let's do one more. Y is equal to 4 minus x squared plus 3x. And the first thing I want to do here, I think, is to put the right side here into standard form. Switch the x and y. Set the equation equal to 0 by subtracting x from each side. Identify your a, b, and c. A is negative 1, b is 3, and your c is 4 minus x. Again, I just think that's important. Then use quadratic formula. Y is equal to, yes. No. No, and that's a good question. Did you hear what she said? She says, couldn't you multiply everything to make that leading one a positive at y? Because that's a lot easier sometimes. And the answer is no, because the original function there is in blue. That's the original function. And if you did this, multiplying everything by negative, you'd have to multiply the y by a negative. Okay. The original function is an upside down parabola. And if we change it, then it's going to be a right side up parabola. So we don't want to change the way it looks. So we have to leave it the way it is, if that makes sense. All right, so the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. Okay. So y equals negative 3 plus or minus the square root of 9. All right, let's figure out the discriminant now. Negative 4 times negative 1 is 4. Positive 4. 4 times 4 is 16. And 4 times negative x is negative 4x. All over negative 2. Simplify inside here, the radical. Nine plus 16 is 25. Minus 4x. All over negative 2. Okay, hang in there with me. Do you think I can take that square root of 25 and take it out of there? No, because it's not factored. I can't. And I can't take the square root of the 4 either, can I? No. All right. What I can do, though, is I can divide all three terms by a negative. Because I don't like that negative in denominator. So negative 2 divided by negative 1, that's a positive 2. Divide the negative 3 by negative 1, I get a positive 3. Now I got plus or minus. Divide both of those by a negative. What do you think I'm going to get? Plus or minus still. So it's not going to change anything there. And square root of 25 minus 4x. Okay, a little bit involved. But this is the inverse. Find the inverse. That's the inverse. Switch the x and y. Swap for y. The next topic you will have I need you to turn to page 526 in your book. And I want you to look at page problem number 37. Page 526, problem 37. All right, that's what it looks like. The more you do of these, the more it'll be kind of easy. Can anybody tell me what the answer is right away? Okay. What I would do in your calculator is do this. 0.5 parenthesis. Now go to your math program in your calculator. Scroll down to number 4, I believe, where it says the cube root. And then plug in, it should bring up a parenthesis. Does it? All right. Then you're going to plug in 8. Close the parenthesis on the 8. Close the first parenthesis. And then raise it to the 6th power. And your answer should be 32. Okay? Sometimes when you get really good, you realize that the cube root of 8 can be written as 8 to the 1/3 power times 6. What do you do with the exponents? What do you do with the exponents? You multiply, right? And 1/3 of 6 is 2. 8 squared is 64. Half of 64 is 32. Okay. The next problem, number 38. 2 times the 4th root of 625. And is that squared? Okay. In your calculator, I'm going to try and write this on the board. I usually show on a calculator, and I might be able to show you guys how I do this on a calculator. All right. Now I want the 4th root, so I'm going to put a parenthesis, and then I'm going to enter the number 4. And then we're looking for the symbol in your calculator that looks like that, because now it's the 4th root. That's also in your math program, and I believe it's number 5. Is that correct? So we hit 4, go to your math program, And you scroll down to number 5 and enter on that. That tells you I want the fourth root. Now we can put in 625, close your parenthesis, and then square it. And we should get 50. Okay? All right. Your homework is on page 525 and 526. 12 through 26, the evens. 39 through 51, the odds. 54 to 62, the evens. And 64.